Hello, this is Embedded Team 4 and Huyan Cha as announcer. I'll introduce about our project blackjack-copilot. Have you ever played card game with friends? Playing familiar card game is enjoyable, but if someone suggests a new card game, it can be difficult to adapt to and memorize the new rules. Proper, Properly understanding and enjoying a card game requires practice. However, as mentioned earlier, suddenly trying out a card game can be challenging. Therefore, to playing card game, some form of the assistance is needed. Since it is difficult to receive such assistance from family every time, I thought about implementing an application that allows one to practice and play alone. To do this, the application must be able to understand the state of the card game. It is very inconvenient to manually input the value to understand the state of the card game. Therefore, by using an object detection model called YOLO with we can read the card game board. After reading the information, we need an algorithm to assist the user by suggesting what action to take. This can be implemented using decisive algorithm or AI among other methods. Therefore, we can provide assistance in real-world card games through object detection and recommendation algorithm. Among various card games, we aim to demonstrate that assistance can be provided through the implementation of object detection and recommendation algorithm based on the card game blackjack. Blackjack is a simple card game where you win by having a hand that is greater than the dealer's hand without exceeding 21. Essentially, blackjack can be played using play cards. When the game starts, both dealer and player receive two cards each, with dealer revealing only one card. Based on the two cards they have, the player can choose to take action such as hit, stand, or split. Any other things so far. For instance, hitting means take one more card, standing means not taking any more card and directly comparing with the dealer. And and there's special rule here. The ace can be considered as either 1 or 11. If the total value of the card exceeds 21, the ace is considered as the 1, otherwise it can be considered as the 11. So let me see one example. In this case, since the playing player's card is the 21, it is calculated as 11 because it does not exceed. In the other case, before the hit, the total is the 17, which does not exceed 21, so the ace is counted as a 11. However, after the hit, the total exceeds 21, so the ace is counted as a 1. And in this case, the player wins. And further, player can get more card whenever player hits. But however, you have to know if you exceed the 21, you're gonna be a lose the in game. So, in blackjack, the decision made after receiving the first two cards is very important. For this situation, a lookup table is provided recommending the next action based on the initial two cards and the dealer's card. A lookup table calculates the most effective action probabilistically and provides a decisive action algorithm. Therefore, it does not use a separate artificial intelligence model. The lookup table used in the project can be referenced from the provided source. To build the project, we used YOLO V8 for object detection. The dataset was provided by RoboFlow. The dataset contains 10 million 100 playing cards in image, which formatted to be suitable for YOLO V8 training. So we initially trained for 10 epoch and then further trained for an additional 3 epochs using the same dataset. The classes of the image are composed of the number and shape combinations. The parameters used for training are as follows in the slide. As can be seen from the train results, adding 3 additional epochs results in overfitting, causing an increase in loss rather than improved performance. However, although overfitting occurred, it was sufficient to draw meaningful results. This photo can be tested by running the file in the corresponding path of the repository. Now that we can distinguish the card in the image, we need to differentiate between the dealer's cards and the player's cards. Therefore, some form of the clustering is required. For the clustering algorithm, an AI model such as k-means can be used, but in this project, clustering was performed based on the threshold. Therefore, if two objects exist within a specific threshold, they are included in one cluster. Based on the clustered information, the getRecommendedAction function returns the appropriate action. The, the lookup table is implemented as a string matrix, allowing the mentioned function to quickly access to the table and provide the recommended action. Then let's try out our project. It's gonna be worse in case detecting the cards and the clusterizing the cards and how how we get the recommendations. So firstly, you have to run the code main app.py. So once we run this code, you can see the one window it pops up. You can find the section for dealer's card and your card. This means the player's card, and there is the recommendations and the the image from the webcam. So let's set up the card in this camera. So one for open, one for closed, and once we give give two open card, then we can get the results that is the must win case, either or stands. And another example for 7 and 3, they give the recommendation with hit. So let's try to give another card to player. So once we give the 9H, then they give the recommendation about just stand. So we can find our project can give the correct recommendation action. So we're gonna wrapping up this presentation. So the objective of the project was straightforward to assist players in card game by recommending optimal actions. However, enhancing the quality of these recommendations proved to be a significant challenge. The core of the issues lie on the how we cluster the cards. To provide accurate recommendations, our system relies on properly distinguishing between different cards on the table. This is where clustering comes from into play. We use the deterministic threshold clustering method. While this method is simple and efficient, it has limitations. Specifically, it struggles when the position of the card are disorganized. In practice, if the cards are neatly arranged, the clustering works well, but in real-world scenarios where cards might be scattered or overlapping, this method cannot be reliably separate them. This limitation directly impact the quality of the recommendation of our system can provide. In conclusion, the quality of the card clustering is crucial. The better we can cluster the cards, the more accurate and useful our recommendation will be. Therefore, improving the clustering algorithm is essential for enhancing the overall effectiveness of our recommendation system. While developing our system, we encountered significant challenge with the object detection model occasionally confusing the cards. To address this, we employed various techniques including the data augmentation and image binarization. Despite these efforts, improving the model performance remained difficult. Then we realized in, influencing our results was the quality of the video input. Variation in video quality introduced inconsistentness in detection accuracy. To mitigate this, it is essential to position the camera steadily to ensure a clear and consistent video feed. By stabilizing the camera and ensuring high quality video input, we can significantly improve the accuracy of the card detection. This allows us to achieve the intended result of the providing accurate recommendation based on the detected cards. You can download and try this code as it works. So please try this code and give me any other feedback to our improving our projects.